Okay, so what we're doing here as well is we're going right back to the start of the unit, week 1, where we're finding equations of lines. And when I give you a recap sheet like this, Rainey, my instruction would be, look at your notes book. Okay, I've given you a notebook, it's got examples in there, and the examples often very closely mirror the questions on the recap sheet here. So let's get started. We have find the equation of a line passing through the points. We have x is 2, y is minus 2, and we have x is minus 4, y is minus 5. Okay, so we have two coordinates. Determine the equation of a line passing through them. So the equation of a line, right, is y equals mx plus c. That's the equation of a line. That means we need to find m. We need to find the slope. So we're going to use the slope formula. All right, the slope formula. y2 take y1 divided by x2 take x1. Okay, that's the slope formula. That's going to tell us the steepness between those 2 points. So we'll go through. It doesn't matter which one we call which, as long as they have the same, the same subscript, x1, y1, x2, y2, and we'll do y2 take y1. So that's going to be minus 5, take away minus 2. Divided by x2, take x1. And we'll simplify this. We have minus 5 plus 2. And we have minus 4 take 2, minus 6. And minus 3 divided by minus 6, well, that's just going to be positive half. That's the simplest way that we can write it. So the equation of this line has a slope of half, right? We have y equals half x plus c. Okay, next we need to determine the value of c. And we do this by substituting in either of these coordinates. It doesn't matter which one we put in, both of them lie on the line, so both of them will satisfy it. Let's put this one in. We have when x is 2, y is minus 2. So I'm going to put minus 2 where the y is, and I'm going to put positive 2 where the x is. Sorry, Carmi, you don't have one either. Oh, you got one? Yeah. So we need to solve for c now. Minus 2 is 1. Half times 2 simplifies to 1. And then we will take away 1 from both sides. Take 1 from both sides and we'll have c is minus 3. Okay, so that's quite a drawn out process, all right? But that's a skill that we do need to know, all right? This is sort of fundamental if you're moving on to, even if you're doing general maths next year, you do equations of lines, all right? So we found m, we found the slope using the slope formula. We put the slope in, okay? And then we go, all right, now I'm going to use one of these coordinates to determine the value of c. Now let's answer the question. Y is half x, take 3, okay? Y equals mx plus c, y equals half x, take away 3. All right, part B. Determine the x and y intercepts of the line. What's up, Ruby? You okay?
Yeah.
All right, so determine the x and y intercepts of the line. So, y-intercept, if you think about here's the Cartesian plane, here's the equation of a line, all right? Y-intercept occurs when the x value is 0. So when we put x is 0 into this equation, half times 0, we have the y-intercept is minus 3. Now, of course, we know that's the case because y equals mx plus c, m is the slope, c is the y-intercept. We know the y-intercept for this line is minus 3. We should be able to see that from looking at it. But nonetheless, the y-intercept, the int, always occurs when x is 0. If we put x is 0 in, y is minus 3. So let's answer part B. The y-intercept is -3. Next we need the x-intercept, and this is a little bit trickier to solve, okay? That's where it crosses the x-axis. And what do we notice here? We notice that the y value is 0. At this point, the y value is 0. So if this is the equation of a line, we put in 0 where the y is. And we want to solve for x. We want x by itself. We want to know what's the x value when the y value is 0. Okay? Y-intercept occurs when x is 0. X-intercept occurs when y is 0. So let's solve this. We're going to plus 3 to both sides. Okay, we've got half x. The way we get rid of half, we're going to multiply both sides by 2. X is 6. Okay, so our x-intercept is 6. All right, so we found the y-intercept. We can see that from the equation of a line. We found the x-intercept. The x-intercept occurs when y is 0. We put 0 there. We've solved for x. Okay, determine if the coordinate x is 2, y is 5 lies on the line. So, if a coordinate lies on the line, then it will satisfy the equation. So we're going to test if x is 2, y is 5 satisfies this equation. All we're going to do is substitute these coordinates into this line and check, does the left-hand side equal the right-hand side? So we'll put 5 where the y is, we'll put 2, we'll put 2 where the x is. Is it true that 5 is equal to -2? No, they're not the same number. Therefore, this point does not lie on the line. It will lie on the line if the left-hand side and the right-hand side are the same number, but they're not equal in this circumstance. So this coordinate does not lie on the line. Another way we could determine it is to go, well, when x is 2, the y value is -2. So that means when x is 2, the y value can't be 5. That contradicts one of the points we know is on the line. All right, so we sub it in, and we see that the left-hand side is not equal to the right-hand side. Okay, so far, all of these skills we've done have been from the first and second week in our notes book. We've gone from 11A in our notes book through to 11G. Okay, sketch the line that you've found. All right, I'll clear some space. We're going to sketch the line y equals half x, take 3. Now, knowing what we know about our graphics calculator, if we want to sketch y equals half x, take 3, we could just type that in our graph and look at it from our graphics calculator and copy it over. Absolutely, that's perfectly suitable. However, if we're going to sketch it manually, we've got a Cartesian plane here that goes from -10 to 10 and -10 to 10. So I suppose there's like quite a few ways we could do this. Okay, I'll explain the way we start with, which is where we plot the y-intercept. The y-intercept is -3, so I'll go -1, -2, -3, -4. So here's the y-intercept. And it has a slope of 1 on 2, right? M is 1 on 2. Remember, slope is change in y divided by change in x. All right, so we're going across 2. X is changing by 2. Y is changing by 1. We're going across 2 spaces, up 1. Across 2 spaces, up 1. And then we draw a line through those points. Okay, so that's graphing the equation of a line. That's in y-intercept form. However, we've also found the x-intercept. We know the y-intercept is -3, the x-intercept is 6. So that means you could just go, here's 2, 4, 6. Here's the x-intercept, here's the y-intercept. It passes through this point and this point. Well, we just get our ruler out and sketch a line that goes through the x-intercept and through the y-intercept. That will definitely be the most efficient way. The reason we did the long way first is to demonstrate that's how we learned it when we did it first. Are there any questions so far? Okay, so that's all equations of lines in y-intercept form. Next, we have the equation of a line in general form. We have 3x, take away 2y is minus 12. This is the equation of a line in general form. This is question 2, right at the bottom. It says, sketch the graph of this function on the Cartesian plane above. Now, when we're sketching from general form, what we do, we identify the x-intercept, we identify the y-intercept, and then we draw the line through them. So we know, right, y-intercept occurs when x is 0, okay? So if I'm going to find the y-intercept of this line, well, I'm going to put in x is 0. All right, I'm going to obscure the x. If we cover up the x, we have minus 2y equals minus 12. Divide both sides by minus 2. We have the y-intercept is 6. All right, y-intercept occurs when x is 0. X-intercept occurs when y is 0. So if we're going to do the x-intercept, we cover up y, we have 3x is minus 12, x is minus 4. All right, then we'll go, all right, well the x-intercept is minus 4, that's going to be, your grid's going to be better than mine. X is minus 4 is here. The y-intercept is 6, so what have we got? That's 3, that's 3, that's 6. And we just go straight through both of them. Remember, we draw the arrows to demonstrate it's going on forever. It's not constrained. All right, any questions? Cool. Okay, so that's all of chapter 1. Let's flip the page, and we've got these beautiful graphs here, for which we're going to find if they're functions or relations, and we're going to determine the domain and range of them. So I'll sketch both. Okay. Asymptote at y is minus 2, like this. And we have point here. All right, so the first question is it a relation or is it a function? Well, a function is the special type of relation that passes the vertical line test. All right, so you run a vertical line along it, and we can see that the vertical line only crosses it once, okay? It's only crossing it once. Therefore, yes, this is a function, all right? The technical definition, each x value has only one y value. Everywhere along there, you have only one y value that matches each x value. All right, if we move on to the next one here and we perform the vertical line test, okay, so we run a vertical line along the graph. All right, we can see here at the y-axis, it's crossing it twice. That the x value here, when x is 0, it has two y values. It fails the vertical line test. It is not a function, it is a relation only. All right, so that's the first one. Okay, the next part says find the domain and range. Okay, so for our first one here, we've got arrows going in both directions for the x. There are no constraints on x. So we say x belongs to the set of all real numbers. X can be any value. All right, when we think about the possible values of y, we should think, right, the lowest the y value could be, there's an asymptote here, all right? And so that asymptote tells us it's going to get really close to it, but never touch it. So the lowest the y value can be is minus 2. It never reaches it. It never reaches the asymptote. So we don't include that point. Minus 2 less than y. And then the highest it goes, well, it goes up to infinity. So we'll put infinity there. So remember when I was teaching domain and range, I said, first we'll make a statement about the range. Then we drop the infinity. So we'll go -2 is less than y. All right. Anytime we have infinity, we drop infinity off the domain and range. And then we flip the inequality, right? We're going to flip it so that it says y is larger than -2. Okay, we must always write the variable first. Okay, everyone remembering domain and range? That's a bit more fresh than lines. Yep. Okay. Good. Okay, on to the second one here. All right, so domain, possible values of x. So we're going, all right, well, what's the point that is furthest to the left? And it's here. This is the coordinate that's furthest to the left. So the lowest x value is -2. We're going to include that point because it touches there. And then we go, and then what's the point furthest to the right? Well, it's going that way to infinity. This point is not the furthest to the right. This one goes further. It keeps going. So we have infinity. We drop the infinity. And then we reverse the inequality. Okay, we always place the variable first. And like now read the statement. What is it saying? It's saying the x value is larger than or equal to -2. Well, at this point, the x value is -2, and every other x value is larger than it. So that's a perfectly suitable statement. Now, if you can look at it and go straight to there, perfect. Do that, all right? But you do have to write it properly, okay? We do expect this, this syntax, this notation. Okay, so that's for the domain. Let's do the range. Okay, range is possible values of y. So the lowest value of y, the lowest point on the graph is here. The y value is -2. All right, so the lowest value of y is -2. We'll include that point. So we have -2 less than or equal to y. And then the arrow here tells us it's going up forever. So that's going to be infinity. We drop the infinity, and then we flip the inequality. So our domain, x is larger than -2. Our range, y is greater than or equal to -2. All right, any questions about domain and range? Very good. Okay, we've got question, we had 2 questions too. Now we're on to question 3. Consider the function f of x is 5x take 2. And g of x is 2 take away x. Okay, so this is from composite functions, 3D, and we found this challenging when we first did it. I think we sort of got it in the end. So we're asked to find f of g of x. All right, so f of x is eating g of x. It's inside its belly. So what we've got to do is we've got to get g of x, and we're going to put g of x into f of x, and we put it everywhere there's an x, right? So that's going to be 5, and then we put all of g of x where the x is there. 2 take away x, and then we have take 2. Then all we'll do is expand and collect our like terms. So the 5 here will distribute, we'll have 10 take 5x, that -2 is hanging out, and 10 take away 2 is 8. All right. B, we've got to find g of f of x. Okay, so this time, g is eating f of x. All right, f of x is in the belly of g of x, right? So what we'll do, we're going to put all of f of x, this whole function, into g of x everywhere there's an x. So we have an x here, that's where it's going to go. It's going to equal 2 take away, and we're going to put it in brackets because that's where we're substituting the function in. F of x is going there, so we're putting it here. 5x take 2. Okay, next, that negative is going to distribute. So we'll have 2 take 5x plus 2. All right, negative and a negative make it positive. And that gives us 4 take away 5x. Okay, so there's our composite functions. That's question 3. And the last one here we have is some sine diagrams. So, draw a sine diagram of y is x plus 4 divided by x take 2. So, we will look at our calculator, but to begin with, I want to identify the important points just by looking at the function. Remember, if we have y equals a divided by b, the roots will occur when the numerator is 0. Roots, x-intercepts, when the numerator is 0. Asymptote, undefined, asymptote when the denominator is 0. Okay, so roots when the numerator is 0, asymptotes when the denominator is 0. So, to find the x-intercept, x plus 4 is 0, the numerator is 0. Take 4 from both sides. So the x-intercept is minus 4. To find the asymptote, well, that occurs when the denominator is 0, plus 2 to both sides. We have an asymptote at x is 2. Alright, so if we're going to sketch this on a sine diagram, here's our axes. Well, minus 4 is the root, and positive 2 is the asymptote. And then we'll determine its shape on our calculator. So I'm just going to sketch it on Desmos. You guys can sketch it on your calculator. But we have x plus 4 on top of x take 2. Alright, and so if we zoom out, we can start to see, yep, there's the root. Okay, there's that root of minus 4. That's what we expect. This is where it's crossing the x-axis. We can see it's positive to the left of that. So we have positive here. In between the root and the asymptote. Now your calculator won't draw an asymptote, but you can observe it. You can see, well, either side of that point, it's shooting up to the sky and shooting down to the ground, right? So we can anticipate there is an asymptote there, and the more and more you zoom out, the more evident it will become. So I'll just zoom out a bit just to really show you. There's an asymptote there, okay? It doesn't exist for those values. We can see that from the graph. So what we see anyway, between the root and the asymptote, it is below the x-axis. And then after the asymptote, it's completely positive. Okay, it stays above the x-axis. So that is our sine diagram. Okay, so that's a pretty thorough recap of of sine diagrams and our unit so far. Any questions? Excellent. Okay, so let's now open up our notes books. We're going to go through 3 G points.